Okay, so today we are going to take notes on the difference between theoretical and experimental probability. Theoretical probability is what should happen. In an experiment. So for example, if you would toss a coin 100 times, you would expect 50 heads. So that's our theoretical probability. So if we toss it 100 times, in theory, we should get half of them are heads and half of them are tails. Experimental probability is what actually happens after an experiment of many trials. Oops. So the interesting thing is a theoretical probability would be the same for everybody, but experimental probability can be different for different groups of people because it is based on what happens when you try the experiment. Just as a side note, whenever we're talking about probability in general, especially when we're writing it as fractions, we always want to simplify when possible. All right, we are going to use the game rock, paper, scissors and as an example to compare theoretical and experimental probability. So with theoretical probability, what we're going to look here is, for example, when it's rock versus, if player A picks rock and player B picks rock, it is a tie. But if player A picks paper and player B picks rock, then player A would win. Whereas if player A picks scissors and player B picks rock, then player B would win. Rock beats paper, this would be a tie. A would win, A would win, B would win, and it's a tie. So as we can see that when we play rock, paper, scissors, there's actually 9 different outcomes that are possible. So the probability of player A winning, in theory, right, is 3 times out of 9, which simplifies to 1/3. Same thing with the probability of player B. And then the probability of ending up with a tie is also 1/3. So when you play rock, paper, scissors with a friend, you have a 1/3 chance of winning. Now, if we were doing this in class, you would play 25 trials of rock, paper, scissors with a partner and just look at how many times this would happen. So we'll say that player A wins 7 times, player B wins 8 times, and then they tied 5 times. Okay. So now when we look at this, what percent of trials did partner A win? Well, they won 7 out of 25. So with a percent, remember we're going to change it 2 out of 100, so it can multiply by 4. So they won 28% of the time. Player B is 8 out of 25, or 32% of the time. And the tie is 5 out of 25, or 20% of the time. And we can see that on the experimental probability that I just made up, right, that it doesn't quite match up with the theoretical probability, which typically happens. So now let's flip over to the second side. On each of these, you'll kind of see that there are different examples with a table. And so it's going to talk about theoretical based on different situations, like for example here in theory and choosing spinning the spinner versus what actually happens. But I want to jump down to number 11, looking once again at flipping our coin. These were our results from our experiment. So in our experiment, heads happened 58 times, tails happened 42 times. Theoretically, right, we know that when we toss a coin, we should get heads half the time. So in theory, if we were to toss it 300 times, you could either do cross products, or we can figure out that like 2 times 150 is 300, so I would do this times 150, that we would expect there to be 150 heads because it's half of the time. However, based on our experiment, we actually got heads 58 out of 100 times. So now when I look at it compared to 300, I'm just going to go ahead and multiply each one by 3 instead of doing cross products, but I definitely could. And so when I do 58 times 3, I figure out that x is actually 174. So based on our experiment, we would get heads 174 times out of 300. So theoretical and experimental, while they're related, do not always have to match up.